So today we're going to cover section 14.2 on page 660, and it's about two-way analysis of variance. The last time we were trying to get some information about this kind of problems where you have, for example, three groups and you are getting responses from each group. So, and you want to know whether the mean of each group is different from each other. So, for example, let's say that we are collecting the scores for a final exam from three different groups. One group was receiving lectures, other group was having interactive instruction, and finally the third group was a combination of the two previous teaching methods. So what we did the last time is that the responses were written in a column that we're going to say that is Y. Those are my responses. And then we have labels for each group. So the first group was labeled with lecture, the second group was labeled with interactive, and the third group was labeled with combination. These labels are a category. They are categories from a categorical variable. So this is our categorical variable X. So these are responses again, and this is my categorical variable. Then we were able to conduct an analysis of variance by using this new way to organize the information. So essentially we were trying to find whether Y, the responses, were a function of the variable, the categorical variable X. So, and we perform analysis of variance of that. Today we're going to see one more layer of information. So this time we're going to work on a similar problem. So again, we have responses again. Responses are going to go again to a column that we're going to know as Y. So all the responses are going to come here. So these are my responses. But this time we're going to have two different categorical variables. The first one is the same as before. We have three different methods, three different teaching methods. So lecture, interactive, and combination. So the teaching method is going to be then one of the variables is going to be my first categorical variable. I'm going to label this as X1. So this is a categorical variable. But now we know also that these groups that are now six groups, because this group is going to be a group receiving a lecture, and also is going to be for a large class size. And then this is also a group where the class is large, but they receive interactive teaching. And finally, there is another large group that is receiving a combination of both. So we have a large class size, and then we have also a small class size. So this is going to be another group here that is from a small class receiving lectures. Then we have another small group receiving interactive instructions, and finally another group receiving a combination of both, but for a small class. So now what we're going to do now is that these new labels or categories are going to be part of a second categorical variable. So we have one categorical variable, which is a teaching method, and the other categorical variable is the size of the class. And finally, I have my response. So I have now two categorical variables, one response. So I'm going to perform now a two-way analysis of variance. So now I want to know whether the difference of the mean is significantly. So for example, I want to know whether all the means are the same, or at least there is one that is different. But also now we're gonna have an extra hypothesis. The hypothesis that is going to check whether these two variables are going to have a combined effect, or we can find the main effects of each one. Effects is just how you're going to have the responses reacting to the different categories that are here. So it is very important to know whether there is a difference between the teaching method and the class size. If we are not able to distinguish a difference between those two, then we cannot proceed with the exercise further. So that's what we call an interaction. So the first hypothesis is going to be testing whether there is an interaction between these two categorical variables, or in other words, we want to know whether the effects from one are going to be distinguishable from the effects from the other categorical variable. If you have kind of overlapping effects, if there are overlapping effects, then this analysis is not going to work. So we want to be sure that if we say there is a difference in one group, the difference is due to some of the categorical variables, not from both, or from the interaction. So we're gonna have then we're going to need to set our hypothesis. So that's what we're going to write here. So anytime that you conduct a two-way analysis of variance, you're going to have three kinds of hypotheses that we're going to test. So we're going to start with the first null is going to be there is no interaction between factors. So factors are our categorical variables. In this case, x1 is one factor and x2 is the other factor. So for this kind of test, we're going to use always alpha equals 0.10. So this is important. This is going to be the value, the significant level that we're going to use to say whether there is an interaction or not between these two factors. Then the alternative is going to be that there is an interaction. There is an interaction between the factors. Between the factors. And then we're going to use a p-value. We're going to use a p-value to make a decision. To make a decision. So if you reject the null, then you stop. So you cannot go further. You cannot do the next testing. But otherwise, if there is no interaction, if the null prevails, then we're going to have a new null. So now the next thing is we're going to test the null that there is no an effect. There is no effects. There is no effect from factor 1. From factor 1. So we're going to check whether x1 is causing something on the responses, is affecting the responses. And the alternative is that there is an effect. There is an effect from factor 1. Then you can also check the other factor. So you're going to check the null that there is no effect from factor 2, and also the alternative is going to be that there is there is an effect from factor 2. So for these two testings, for these two tests, the alpha is going to be different from this one. So you're going to read carefully the problem to know what alpha you're going to use. Most of the time we're going to use 0.05, but it's going to depend. So if this is the value that we're going to use if alpha is not given. So pay attention. Alpha is 0.10 only when you are testing interaction between the factors. So this is important. So we're gonna solve a problem from this section, and then you're gonna have the chance to solve a similar problem for your classwork. So we're gonna work on problem on an example 4.9, 14.9. So we have example 14.9 on page 662. So let's see what's the problem. So the problem is the following. So you have here example 14.9. So this problem is about the scores. So the following table presents final exam scores for students taught by one of three teaching methods and one of two class sizes. So this is the same values I'm showing you, I was showing you before. So we have here the teaching method. We have 6 groups. So this is one group. So they receive lecture and it's a large class. Then again, interactive teaching from a large class, a combination of both teaching methods and a large class, and the same thing for small classes. So we have 6 groups. So we're gonna solve this problem. So let's see. We're gonna start writing our hypothesis and everything. So in this case, we know that we're gonna start. Our first part is just interactions. So we're gonna look for interaction. Look for interactions between the teaching method and the class size. So this is the first part of the problem. So essentially that means that the null is that there is no interaction between the teaching method and the class size. So in other words, the effects from each are not overlapping, so can be distinguished clearly one from the other. And the alternative is going to be that there is an interaction. There is an interaction between those factors. So teaching method between the two factors. So x1 and x2. So remember the teaching method is going to be x1 and the class size is going to be x2. So those are my hypotheses. So now we're going to enter the information into R. So we're going to rearrange the table as we talked the last time. So this is what we're going to do now. So we have, as you remember, I'm going to just give you an overview what we're going to do now. So we have a table that shows the information from 6 groups. So we have lecture, interactive, and a combination, and we have a large class and a small class. So this is teaching, method, and this is size of the class. So we're gonna have all these responses, and we're gonna create again a table, a different table where we have x1, x2, and the response y. So size is gonna be x2, the teaching method is gonna be x1, and the responses are gonna be our y. The responses. What are the responses? The final exam scores. So what we're gonna do then is we're gonna have a column of responses. So we're gonna have something like this. So I'm going to write first the responses. I'm going to read them from the table. So you can read 62, 74, 68, and 69. So that's the first group. So you can check anytime the table. So I'm getting 62, 74, 68, and 69. And you can see that these 4 values correspond to lecture. That's the first categorical value, and large. So I'm going to write here lecture for these 4 responses. And in the other column, I'm going to write large, 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 and large. So, and we're gonna do this with the other 5 groups. So I have another group that says 87, 75, 69, and 84, and this is interactive, and this is also for large. So these 4, okay, are for interactive and large. Then I have another group with 66, 66, 81, 75, and this is for a combination and also for a large group. So that's my first 3 groups that you have from the first row, if you check. So I just wrote these 3 groups on the top corresponding to a large class, and the 3 different teaching methods. Now I'm going to do the same thing with the other. So I'm going to have again y, x1, and x2, and now it's going to be 75, 77, 82, 74, and this is now for a lecture again, but now is for a small class. Then I have 4 more values: 75, 87, 89, and 94, and these are for interaction and a small group. And finally, the last group is 76, 84, 90, and 93 for a combination of both classes and for a small group. So I just reorganize the data. So the original table, very simple. It's very simple here because you are not repeating many times the word lecture. You are not repeating many times the word interactive. So these tables are good to understand information, but these are not good to to let know our software or any other computational device to know about every single response. We need to provide the information for every single response. So 62 is from lecture and large class. This 94 is from interactive and small class. This 75 is from combination and large class, and so on. So that's the reason we needed to organize our data in this way. So now for every response, you have its corresponding categorical variables. Now we're going to enter this information in R the same way that we have been doing this in the past. So we're going to use list. So we're going to have, for example, we're going to start writing, let's say we're going to start with x1. So x1 is going to be lowercase c, and then what is x1? So x1 is 4 times lecture, then 4 times interactive, 4 times combination, 4 times lecture, 4 times interactive, and 4 times combination. So I'm going to write that. So I'm going to repeat lecture 4 times, and I'm going to repeat interactive 4 times, and I'm going to repeat combination 4 times. So it's very important to use the quotation marks because these are labels, these are categorical. These are categorical data. Okay, and then don't forget the commas between every repetition. So then I have I'm going to repeat again lecture 4 times. Then I'm going to repeat interaction 4 times, and I'm going to repeat combination 4 times, and I'm going to close the parentheses. Don't forget this parenthesis matches this parenthesis. So that's the way that you prevent mistakes. So that's this column here, the column corresponding to x1. So this column, I just wrote the R command for x1. For x2 is going to be simpler than the previous one. From x2, I'm going to enter the following. So I need to enter, you can see here, I need to enter 12 times the word large and then 12 times the word small. So this is easier. So I just need to write, I need to repeat the word large 12 times, and then I'm going to repeat the word small 12 times too, and then I'm going to close this parenthesis, the matching one. Then I'm going to enter the responses. So the responses is the first column. The responses is just the numerical values. So I'm going to enter all these values by following the same order. So order matters, so be careful that you enter the values. So what I do is I'm going to write the lowercase c, and I'm going to start in the next row to match the table. So 62, 74, 68, 79. I can leave spaces here just for me to see that I'm starting a new group. So you can leave 3 empty spaces here. 87, 75, 69, 84, more spaces. I'm going to write the third group, 66, 66, 81, 75. Then I'm going to move to the next row to enter the next row that corresponds to the table. 75, 77, 82, 74, 75, 87, 89, 94. I forgot this comma here. So 76, 84, 90, and 93, and a parenthesis at the end instead of a comma. So now I have all the information corresponding to the to this problem. So both the categorical and the numerical variables. So now we're going to create just in the final step, you just create the data frame. So we're going to do that. So I think first I'm going to enter these values on R for you to see. So I'm going to move to R now, and I'm going to enter all the information corresponding to this problem. So let's open our R console. So now you have your R console. I'm going to copy all the information I just mentioned. So I have here what I just said before. So my categorical variable x1, my categorical variable x2, and the response. So now we're gonna continue with the second part. So this is the first part. This is the most important part, that you enter the data correctly. Because if you miss a data or you change the order, then you're not going to get the answer. So the next part is just put all these variables together. So we're gonna join the variables in a single set, so to speak. It's a single data set. So we use a command to do that. We're gonna say that my data is gonna be a data frame where you're gonna have x1 is the first column of that data frame, x2 is the second column, and y is the third column. Then we're gonna create a linear model. Remember, as we did the last time with one-way analysis of variance, a linear model is at the root, is at the core of the analysis of variance. So we're going to use LM, lowercase l, lowercase m, and we're going to say that we're going to have a model where y is going to be a function of xy times, sorry, x1 times x2. So, comma, we're going to use the data frame that we just created here. You can type here my data if you want, and my data here too. So we can use that, my data. Then you call this my data. And finally, you're going to call the analysis of variance. Sorry, this is a parenthesis, analysis of variance of the linear model. And we're going to copy the summary table, and we're going to interpret the summary table. So these are the next steps. So let's do that in R to continue with our exercise. So what is my R console is here. So I'm going to say that my data is a data frame where I have x1 in the first column, x2 in the second column, and y in the third column. And you can check that if you call my data, you're gonna see the data frame. We can do that at the end. So let's continue with the, then I'm going to have a linear model. We can say my linear model. My linear model is gonna be LM y as a function. So you use tilde and x1 times x2, and we're gonna use my data. And finally, we're gonna call the analysis of variance. So it's gonna be ANOVA by using my linear model. So that's what we need to conduct our analysis. So we're gonna copy the entire table to be able to get our responses for the different hypotheses, the different nulls that we're gonna have. So I'm going to stop here for a moment just to copy the table and give you time for you to copy also the table. I'm just going to stop the recording. Okay, then we copy this table, analysis of variance table, into our notes, and then we're gonna start doing our, we're gonna make our decisions. So this is the table. So we're gonna start testing. So the first part is we're gonna test the interaction between x1 and x2. So we're gonna see whether the effects from teaching and the effects from the class size overlap or not. If they don't overlap, perfect. That's a good thing for us. So then the null that we are testing as is no interaction. There is no interaction, and the alternative is that there is an interaction. There is an interaction. So to do that, remember we compare the p-value and alpha to make a decision. So where are we going to find the p-value corresponding to the interaction? If you check the table, you're going to read x1 here, x2, and then x1 colon x2. So this row here, this row corresponds to the interaction. So this is the analysis of variance corresponding to the interaction. So we're going to look at this row, and the last column, it says PR greater than F is just the p-value. So as I mentioned the last time for the one-way analysis of variance, this column is this column contains the p-values. So what is the p-value that we need for to test the interactions? That's the p-value that we need. So we're going to use this p-value here. So the p-value is 0.6335 47, and alpha for the interaction is always 0.10. So we're going to compare these two values. You're going to see that the p-value is greater than alpha, so we cannot reject the null. So we cannot reject the null. So we can write just there is not enough evidence to reject the null. So in other words, there is no interaction between x1 and x2. So between the teaching method and the class size, so we can proceed with the rest of the analysis. So proceed with the rest of the analysis of variance. Otherwise, if you reject the null, you stop there and you say, I cannot do anything with this information. So both the teaching methods and the class sizes seem to have overlapping effects, so I cannot distinguish one from the other. But in this case, we found that there is no interaction. We can now test, for example, the next, you can test either x2 or x1, so the effects now, it doesn't matter the orders. We're going to test first main effects of x2. So my null is that no main effects of or from or due to class size. So that's my null. My alternative is that there is an effect. There is an effect due to class size. So we're gonna again compare p-values and alpha. So the p-value, you know where to find the p-value. So x2 is here. So now the p-value that I'm looking for is this one. So I'm going to write p-value equals 0.002123. So I have the p-value there. I'm going to use alpha equals 0.05. You check with the problem whether you need to use a different significant level when you are doing just the one-way analysis of variance, because these are the one-way analysis of variance. I'm doing the analysis of variance corresponding only to x2. So I compare these two and I find that the p-value is less than alpha. So now you can reject the null. So you're gonna write that there is enough evidence. There is enough evidence to reject the null. So there is a main effect of class size. Okay, so now the last case is when you are testing main effects of the other categorical variable, in this case x1. So my null is that no main effects of teaching method. So x1, the alternative is that there is an effect due to teaching method. And then we get the p-value from our table. So you check the table, and now the p-value is 0.0310. So I'm going to write 0.030310. Alpha is 0.05. So you can see that the p-value is again less than alpha. So we reject the null. So you can say that there is enough evidence. There is enough evidence to reject the null. So you can conclude that there is an effect of the teaching method. So that's the end of the story. So that's two-way analysis of variance. So now you're gonna play with one exercise, and there are many in the book. You can do this. You're gonna need to work this exercise for the quiz that you're gonna have to solve online. But for the final exam, I think you are not going to need to do a two-way analysis of variance. I think it's gonna be just one-way analysis of variance for the final exam. But yeah, be ready, be prepared for that. You need at least this for the quiz, the last quiz of the semester. So we're gonna go and check section 14.2 exercise set on page 670. So you're gonna solve problem 16. So that's the one that you're gonna solve. I'm going to project now the problem, and then again you're gonna submit your results, your screenshots from your R console, your screenshots from your notes through a PDF file that you're gonna upload by going through the classwork section on Canvas. So remember, you need to press the submit button to be able to do that. So you have here problem 16. So problem 16 is about fertilizers and different zones where those fertilizers are applied. So you have this time you have 9 samples. So 3 different kinds of fertilizers and 3 different kinds of zones where you are applying this fertilizer. So this is the problem. Remember, to check interactions, you need to set alpha equals 0.10. For the other questions, you see here that you're going to use alpha equals 0.05. So this is the problem. And this is the end of the semester with respect to lectures. So we're going to have one more session for review for the final exam.